can you recognize what you should do to make this from that? So what happened was, you got the benzene there, right? It was a 2-carbon chain and then chlorine, but you end up having 3 carbon and then hydroxy groups there. So we are making primary alcohol, but we just add the 1 more carbon. So hope that you are kind of searching your databases and then figuring out if you know any reaction that add a carbon and make an alcohol. Then I hope that you recognize there's a reaction that, first step is making a Grignard, and then by making Grignard by using formaldehyde. That's the key. Formaldehyde comes with the 1 carbon, and then that will become the carboxy groups, which get protonated in the end. So that becomes a primary alcohol. So this is kind of a situation that I want you to recognize. Yes, primary alcohol will be made based on adding 1 carbon. So the reagent that you need to use must be the formaldehyde. What about this? It's kind of a similar looking question. If you really didn't pay attention or count the carbon, you probably would end up using the same thing. But now, this one is 1, 2, 3, 4 carbon. You start with 2 carbon after benzene, now it is a 4. What means that we added 2 carbons. We added 2 carbon, and then we make an alcohol here. So we cannot use the formaldehyde to make this, because the formaldehyde makes this 1 carbon added, not 2. If you think about, I'm going to use the formaldehyde twice, well, you don't know how to convert OH to halogen, so you can actually make another Grignard reagent and then treat with the formaldehyde yet. You really have to do it next semester, but not yet. So I don't think that will be the viable option for you today. So how are you going to add a 2 carbon and then make an alcohol? Then I hope that you recognize the reaction we've been talking about today, epoxide. Right? Epoxide is the one that having a 2 carbon. So with the Grignard, make an attempt in epoxide, it will make a primary alcohol with the 2 carbons then added. So you can see that these two looking very similar, but you really have to make the right choice of the reagents. And that comes from the correct analysis of the products. So that is something that I want you to pay attention here. And then it's kind of a question that, then how are you going to do this? I'm making a primary alcohol again, but I started from here. How are you going to do that? You're going to make a Grignard reagents, and then how are you going to make this? Well, this is a question that is kind of tricky because it doesn't need to be used Grignard at all. I mean, this one, you see 2 carbons here, we see 2 carbon, basically no carbons been added. So it doesn't need to be done by the Grignard. It can simply be done by just the SN2 reactions. Right? If you're worrying about SN2 reactions with the hydroxide, you're able to make an each elimination reaction, then you can probably, using a TP-toxide, well, let me show you that. Using a TP-toxide, and the intention to make the double bonds. Because that reaction with the hydroxide can be a problem. So we are expecting, oh, this is worse. So we are expecting this makes an attack, kicks it out, and that is what you may think. I mean, I'll show you, we can make that. But the problem is, this is a strong base, and there's a hydrogen there. So if the hydroxide pick up this proton, then that will make an each elimination reaction, and then you're going to have these forms. So that's the problem with using base that can also becomes a new compound. So if we don't want to have a competing reactions, what we can do, instead of using this, we probably using a T-butoxide. And then the T-butoxide is not going to be acting as a new compound, that only going to be doing this, and then that's 100% made. But then you gotta produce that from this. So how are you gonna do that, right? You make an alcohol with a double bond, that means that you're doing the hydration reactions, right? You are adding water. But there's a two different way, actually three different way you can do it. Are you gonna do it in oxymercuration or demercuration, or are you gonna do the hydroboration? The answer is you need to figure out is the Markov-Nikoddy products or anti-Markov-Nikoddy products from that, right? The Markov-Nikoddy product is a new compound sitting on the more substituted side. There's a double bonds here. That's a more substituted, that's a less substituted. OH sitting on the less substituted side, that means that that's an anti-Markov-Nikoddy products. So oxymercuration, demercuration is not going to make that. You have to do the hydroborations. So HBr and the BH3 is going to be added, but hydrogen and boron is going to be similar like this, right? The borons are bigger, so substitute is positioning on the less substituted side, and the hydrogen go to the more substituted side. But the boron in the end replaced by the hydrogen peroxide and then sodium hydroxide, you can make that. So, I mean, you can do a simple SN2 reactions like this, but I would expect that would be complicated with an SN2 competing with an E2. So, if you make an E2 100% by using a Berkey base and the hydroboration, it seems to be like a detour, but that means that you have control for every step. So this might be the better way to make it happen. But anyway, that has nothing to do with the Grignard. So seeing an alcohol there, don't be compelled to use a Grignard, right? It depends on what you want to make it. If you want to add a carbon and make an alcohol, yes, you can do it without formaldehyde. If you want to add 2 carbon and make an alcohol, yes, you can do it without this. But if the no carbons need to be added, then it's not a question of the Grignard reaction. It is a question of something else. So you have to figure out what to do.